Hello everyone, this is chapter 4 of our MATLAB series in which we'll be dealing with signals and its types. So what is signal? Signal is a physical quantity that carry information, and it can be your vocals, a voltage or a current waveform, pictures, and etc. Mathematically, a signal can be represented as the function of time, or which is usually denoted by t. Now let's see how we can classify signals. So signals can be classified into different types, like we have continuous and discrete time signals, analog and digital signals, real and complex signals, deterministic and random signals, even and odd signals, periodic and aperiodic signals, and finally energy and power signals. So out of these seven, we'll be discussing three important signal types, which are continuous and discrete time signals, even and odd signals, and periodic and aperiodic signals. Let's begin with continuous and discrete time signals first. So a signal is continuous if independent variable t is continuous at every interval of time. Let's draw this on paint. Here we have, you can see time on x-axis and amplitude A on y-axis. We make a sinusoidal wave like that. Now in continuous time signal, we'll have the value of this signal at every instant. You can see. But on the other end, independent variable n is not continuous at every instant. Like you can see there is a blank space between these lines, so they are not continuous. As you can see that continuous signals are always denoted by x of t, while we represent discrete time signals by x of n. For continuous time signal, we have voltage, current, temperature, and pressure as the example. And for discrete time signals, number of accidents on highway, daily closing index of a stock market, or temperature of patient after each hour can be the example. Now let's try to generate some basic continuous and discrete time signals in MATLAB. So first of all, we are talking about unit step function. As a unit step function looks like the step of a staircase, therefore we call it a step function, and unit is because of the amplitude one. It is also called the Heaviside function. Let's go ahead and see how do we plot it on MATLAB. Type clear all and CLC to clean the window. Now define the time for which you wish your function to exist. Let's say I'm taking t equals -7 to +7. And to plot a step function, we use another function named Heaviside function. So let's take y equals Heaviside of t, and I'm gonna plot it. And for that, we'll use plot command. So in continuous, we take plot command to plot the function, and if we want to plot in discrete, we'll use stem function instead of plot. Now I'm defining the axis for the plot, so I want to see the value from -5 to +5 on x-axis, and plus 4 to minus 4 on y-axis. Go ahead and run the code, and you can see that we have a step function. But notice that it's a kind of a ramp, while there must be a straight line for a unit step or a heavy side function. And to get the straight line, we have to add more resolutions to the time variable. So between minus 7 and 7, let's take the resolution of 0.001, and now run the code again. We can see that there is a straight line which was required. The output plot is starting from there, which means that it is not defined at t less than 0, but the graph is 1 when t is greater than 0. Similarly, if you want to plot this for a discrete time, simply replace plot with stem, as we have discussed this before. This stem command is used to plot the discrete signals, and now run the code again. So here is the unit step function in the discrete time. After that, we have a unit impulse function or direct delta function. It is named after a physicist named Dirac. This signal only exists at t equals 0, where it rises to infinity, and 0 everywhere else. This function has unit area, so that's why it's called unit impulse function. Let's see how it goes on MATLAB. Now, again, define the time for your function to be shown. Let's take t equals minus 7 to 7 again. After that, we'll generate the signal. We know from the definition that this signal only exists at t equals 0. So take a variable named impulse equals zeros and ones and again zeros. So from minus 7 to minus 1, the signal will be 0, and these zeros are generated by zeros command, and then we'll generate 1 at the 8th location. And as we need only 1 time 1, we'll only write 1 comma 1 and then again zeros for the rest of time values. Now plot the impulse like this. So the output looks like a triangular wave, but it is due to the fact that MATLAB by default interpolates all the sample values for the better display. So let's use stem command instead of plot. Now we are getting a proper unit impulse function at t equals 0. On number third, we have a ramp function. Ramp function increases linearly from the point in time where it is not 0. It increases with the slope of your choice. It can either be 1 or any other number. Let's go to MATLAB, and the expression for writing ramp function is written in the comments here. Ramp equals t into u of t, where u of t is unit step sequence, which we have already seen. T is the time duration. Here I take t equals any value from negative to positive. The ramp signal is only valid for positive values of time. That's why we have multiplied t with unit step function u of t. Now for unit step sequence, take u equals zeros and ones. In this initial 10 values will be 0 because of the zeros function, and the next values will be ones. Now to generate ramp signal, I'll type this expression, which is t into u of t. Here we have performed individual multiplication. That's why we have used dot star multiplication between t and u of t. Now plotted by using plot for continuous and stem for discrete signal. Here I'm plotting in continuous. You can set the axis to simply type axis and minus 12 to 12 in x and minus 1 to plus 2 in y direction. So it's a ramp signal. Now let's talk about the sinc function, or it is also known as sampling function. This function arises frequently in signal processing and the theory of Fourier transforms. Its full name is sine cardial, but it is usually referred as sinc function. Let's see how it is plotted on MATLAB. Take t, which show again the time period from minus 5 to plus 5 with the spacing of 0.1. For sinc function, we have a built-in function in MATLAB called sinc. So take y equals sinc of t. Now plotted by plot t comma y for continuous or stem t comma y for discrete. So on number 5 we have signum function. In mathematics, the signum function is an odd mathematical function that extract the sign of a real number. Now the code for generating signum function will be as take n equals minus 5 to plus 5 with 0.1 of spacing. Like sinc, MATLAB has built-in function for signum function also. So take y equals signum of n and now plot in discrete using stem function. So stem n comma y. So these were the basic continuous and discrete time signals that we are going to use in our courses ahead. We'll be exploring more signals as the course proceeds, but for now we'll do these basic functions only.